when products come out, products always come out with bugs, right? So it's very hard to get all the bugs out of your system. So the success, the measure of success of your product, I think is some kind of ratio between its usefulness and the number of bugs or the level of frustration it causes, right? So if that ratio is high, people will use it. And it's just like a scientific theory, I think, if you ask me, because we have many scientific theories explaining natural phenomena. Some do a better job than others, yeah? And but the way that science grows is that you always propose a theory to explain some natural phenomenon, and then you say that theory explains it. So it can explain other things also using this, but you discover certain things that this theory does not explain, like Newton's theory of gravitation, right? It was a successful theory, we still use it, right? But it doesn't explain some small aspect or some aberration in Mercury's orbit, which is actually measurable, right? There is an aberration in everything according to Newton's theory, but the Mercury's orbit aberration is actually measurable by our current sloppy instrumentation standards, right? So it doesn't explain it. And so we say, well, it's a good enough theory, but it's got a bug in it. It doesn't explain everything. But we don't throw it away because we don't have anything else at that point. So we live with that theory, with the bugs, just like we live with Android and with that bug, we live with it until something better comes up. This is Einstein's theory, right? Einstein's theory says it does what Newton's theory does, but also fixes that bug, right? So and so it grows. But what happens is that and that only happens when you have a better product. When you have a better product that does, subsumes the old product and does more, then it'll take over. But usually what happens is that it's very hard to come up with that replacement for what you're gotten used to. So people will just train themselves to live with suffering. Right? We'll say, I'm going to put up with all this bullshit. I'm going to put up with this nonsense. I'm going to put up with this personality of this person and live with them, even though they're so annoying, because there are so many other things they do that I absolutely love. Right? So that's the kind of thing you have with this product. But what happens is over time you discover more and more of these pain points, and you say, okay, that's it. I don't want this anymore. Okay, I'm out of here. And so you say the bugs in this product outweigh its usefulness, so I'm not going to use it anymore. Right? So and it's the same thing with scientific theories, right? So who is this? I don't know. Lagrange? His name starts with L. Lakatos. This is some philosopher of science. Yeah?
Yeah.
Not Lagrange. He's a mathematician, I think. Right? So Lakatos is the philosopher. He said, that's how scientific theories also grows. And you have a theory, it has bugs in it, and we'll live with it. But more and more bugs will start coming in. No, they're there already, but our microscopes get bigger and we can see more and more bugs on it. Okay? So we see a lot of bugs. And eventually we say there's too many bugs here. I don't want this theory anymore. Okay? As long as there's a viable contender, we'll say we'll use the contender. If there's no viable contender to this theory, we still have to use this crappy product, right? So it's all the same. I think it's basically just humans, right? So that's how we live. We live with what we have, and we try to make the best use of what we have. Can I erase the board? Do you guys looking at it? Okay. So I don't forget it when Marty comes. Okay, who else need help? So here, why don't you implement Eliza? All right. So I think you can. Let me see if I can. I'll just implement Eliza. Right. I'll just do it here in some random buffer in Emacs. I'm not going to get into an IDE because I'm probably going to make typos here. So basic Eliza, let me call it basic Eliza.cpp. All right, hash include. Okay. And then I'll write a comment here saying this is a simple version of Eliza. This should really go at the top, which responds to a user input by shooting their question back at them. Okay? And here, I'm just going to have an infinite loop while true, and then if it's an infinite loop, I need to, get out of it at some point. So I'm going to have a break statement. You're already thinking about how you do this, right? So I'm going to say string user input, and then I'm going to print the prompt. So see out prompt. Okay, and then the first ever prompt that I'm going to give the user, I'll just define here. String prompt equals hello there. What brings you to see me today? Right? And then new line. Okay, so I'm going to put 2 new lines maybe. Okay, so that's the very first prompt. So it's going to print the prompt and then get the user input. So I'm going to say, how do we get the user input? Okay, we'll use get line. Okay, get line, cin, comma, user input. Right? Now get line is, I mentioned this last class, it is the safest form. One of the safest ways to get user input. Don't ask the user to type in an integer or a floating point number, get the string, the whole line, okay? And even if you're trying to read a string, get the whole line, not just the first word. Because think about it from the user's perspective, from a user is always thinking that, you know, when they hit the enter key is when they've sent the information to you, yes? That's what the user is thinking. So always do what the user is thinking, and you can't go wrong. Well, most of the time, anyway. All right. So if the user says I've hit the enter key and there's 10 words on that line, then you got to take all the 10 words. Don't take only the first word with C and double less than. You know, even though you're reading into a string, don't take only the first word because the user thinks you've taken everything. So next time you ask the user for something else, they're going to think I'm going to type in a whole new line. But if you took only the first word from the previous input, the next time you ask the user for something, it's going to take the remaining 9 words from the previous input, not the new one. Right? And that causes a runtime error. You don't know what the hell is going on. Yes? You see, always do what the user predicts you'll do. And I think you have a better chance. Okay, so I've got the user input. Now I just want to shoot it back at the user. So I say see out. Let's say prompt equals aha. That's interesting. Why? What makes you say? And then within quotes, I'll just tell the user what they said. Okay. What is it? User input. Okay. And then a question mark. So plus question mark. Oh, and then a couple of new lines. Okay, just to make it easy to read. That's it. That is my very basic ELIZA, which you can basically take and hack and let's compile it and run it too. All right. So let me make sure everything is okay. Oh, I need a break. Okay. Well, I don't need a break. I need a break here. Okay. So let's see. All right. So here I'm going to say if user input equals by or user. You'll find out more efficient ways of doing all these comparisons eventually. Equals quit, because you also want to do case insensitive comparison, capital BYE, but you can handle all that. Okay, and you say see out. All right, you want to thank you for your time. Say that will be $4.97. Okay, and then break. All right, so let's compile this and run it. Where is it? Oh, thank you, Virginia. Is that all right now? Oh, and then I need a quote here too.
Do you need commas for Fibonacci?
Okay, all right. Side conversation on Fibonacci.
Okay.
So the Fibonacci challenge is actually very interesting because you actually need to get it absolutely right and efficient also in order to pass it. If it's not efficient, you'll get all the other rewards, right? You'll get 20 out of 22 points, maybe you'll get it anyway, and you can get the password for the next quest. But if your Fibonacci is not efficient, it will just time out and be killed. It doesn't matter. You can go on to the next quest, but you got to figure out how to get Fibonacci right, okay, if you want the extra credit points. Okay, let's compile this and run. Okay, so I've compiled it, so I'm just going to say basic, what do I call it? Basic ELIZA? Okay, basic ELIZA. All right, hello there. What brings you to see me today? I can say, well, today is a fine and dandy day, isn't it? Okay. Oh, that's interesting. What makes you say? All right. So, but you see that's what we built into the program, right? Anything I say is going to say exactly the same thing. All right. Are you nuts? Okay. And say, oh, all right. That's interesting. Why do you say are you nuts? So, but you see how this code is actually quite simple. So, oh, let's try by. Okay. So, I just feel like I got too much money. All right. Buy. All right, that will be. All right, now I don't have too much money. Okay, good. All right, so so you can and let me put up the code so you can actually copy it if you want. Oh yeah. Oops, not. That's a binary. By the way, this is a binary. It's translated by the compiler into binary machine instructions. That's what I actually added, typed out to the console. This is what the program looks like after the compiler has taken your program and turned it into machine code. This is the ones and zeros, the bits. That's what it looks like. Okay, so let's run the program. Let's show you what the program looks like. Cat basic ELIZA.cpp. So this is the program. It's quite simple. And you can, if you want to change it, all you need to do is simply go in and change this part, right? So you just need to change where you get the user input here. Okay, here, print the prompt, get the user input, you get line, get the user. Now that's the place where you can break up the user input into individual words. Okay, and you pick out word number 5 or word number 6, and say, you can say, oh, if the 6th word is C++, then I refuse to counsel you, or something like that. Okay, be creative. Okay, so you can break it up, or you can say, check to see if the user has talked to you in all caps, right? If the user input is all capital letters, you can tell the user, hey, don't shout, or something like that. Yeah, so yeah, you can do things like that. Yes, Morgan.
I'm getting an error, and I can't.
You get an error?
Something subtle, yeah. With the get line undefined.
Get line is undefined. This is Visual Studio.
Yes.
Okay. Yeah, looks right. Do you have? Go to the top of your code. Line is undefined on Visual Studio. Hash include string just for now. We'll see what. At the top under hash include string string. Try now to see if it. Oh, how come see if the error has gone away?
That error went away, yes.
No, the get line.
The get line error went away.
Oh, good. Okay, there you go. So it's actually in the strings. Yeah. So if you're using Visual Studio, this is really funny. So Morgan had an unknown function on getLine, okay, with Visual Studio, and I don't know why. The string is supposed. I thought string was already included in one of these include files. Not one of these include files. In this include file on a Mac, I've never had this problem because I think so. You have to hash include string, and that makes the error go away. So you do this.
The AP time. Okay, so what I am trying to do.
I looked more into this because I don't think why I don't know why I should require you to include the string library to get line. Because there's so many other string functions you use which are in your IO stream. Anyway. But for now, if you just include the header file, that get line error message will go away. You good, Ben? Jasmine? Oh, no, Morgan.
That was become my situation. 1, 2, 4, 7.
Sorry?
Expression must have bool type, like
Oh, expression must have a Boolean type?
I believe
Okay, that's easy to fix. I'm pretty sure it's, yeah. So which expression is it?